All right. Good afternoon, everyone on the East Coast and Central United States. And for everybody that's on the West Coast, good late morning. My name is Rob McCoy. I am Northeast Rep for Holganix, and I'm here today with Dr. Niedermeyer. He's the Director of Soil and Plant Science for Holganix. He also has 13 patents, BS in agronomy at Penn State University. We are Penn State, and an MS and PhD at North Dakota State University. Dr. Bob, thanks for being here.
For those of you who don't know, North Dakota State University had a run of 6 years in a row being national champs.
Carson Wentz.
Yep, exactly. So, well, I'm glad to be here, and that's me holding up. Anybody know what that plant is? I wonder how many of you do. It's a pea plant, and the one on the left of the screen had been treated with Holganix Bio 800, and the one on the right had not. These things start out as seeds, and I treated them as seeds, and then every other week I treated them up until the time I stripped them of their soil. And I was real disappointed with this experiment because as you looked at it, the tops never showed any difference. And I was so surprised when I pulled the soil off and looked at the roots. The roots really took off on the as opposed to the check. And then I did a literature search, and I found out that this is exactly what we should be expecting from what's called plant growth promoting bacteria that are in our Bio 800. They really stimulate the pea roots by secreting plant hormones that resulted in those longer roots.
And my story is not nearly as fun, but it is somewhat relevant based on that picture. We were just discussing this. So that is in Puerto Rico. That's in Old San Juan, which is getting hammered by a hurricane right now. And I actually just found my name on the old fort in Old San Juan, which is one of the oldest deep water ports in this side of the world. So the agenda for today, pretty simple. We're going to do an introduction to roots, the 7 tactics to improve root health, and then an open Q&A session. But we would like to start off with a few questions to learn a little bit more about who we are presenting to today. So the first question is, what industry are you from?
It's okay. Face this. It's just this as an attendee.
So select one of the following for the industry: lawn and landscape, golf, sports turf, if you're a grower, and if you are a distributor or partner of Holganix.
That's 73% of the vote.
What do we need? At least 80, 85?
I'm thinking 80.
We need a few more votes in there.
77.
Come on, you can do it. By the way, Katie is here and has pretty much lost her voice, so you can't even hear her yelling. But she wants you to get your votes in.
Got 81.
All right, let's see what we got. All right, so 65% lawn and landscape. No golf. Looks like we got one sports turf or a few sports turf. 24% grower, and just a couple of Holganix distributors and partners. So we're really talking to the end users today. We have another question. Are you using a Holganix product currently? And if you are, which one is it? So you can select more than one here. So we have Bio 800 Plus, which is the refrigerated version of Holganix. We have PB1, which would be PB1 or PB1 LTO. Then we have Blue Sky 2100 and or the prebiotic 21020 with armament. And then any of our granular products that are infused with Holganix. And then the last option, I'm not using Holganix yet. Katie, are we up to 80% yet?
82.
Oh, nice job. Let's check it out. All right, 42% using Bio 800, 11% on PB1, 32% on the Blue Sky and 210-20 fertilizers, 32% on the granular fertilizers, and 37% not using Holganix yet. So looks like there's going to be a good amount of information for everybody to take away, regardless of which product you're using or not using yet. So the first section that we're going to go into is the function of roots. Dr. Bob, what do you got?
Just a point of information for all of you, and that is that we're not open for questions until the very end. So what we'd like you to do is to enter your questions as they come to your mind, and then Katie will sort them out at the end of the presentation, and then I'll try to answer your questions. So just really getting back to the very beginning. What are the functions of roots? And really, they're pretty simple. They're just three, and I think if I asked you and you thought about it, you'd come up with the same three. But the anchorage, you got to be able to stay put in the soil, and that's a big function of roots for plants. Support. Most of the weight of a plant is above ground. Now, that's a lot different for you guys who are in turf. It's about 50-50, or maybe even sometimes higher roots in favor of roots versus shoots. And then lastly, roots are how plants get all their water and all their nutrition. There are exceptions to that. You know, there are plants that grow just hanging on the bark of trees, and they get their water and nutrients in large part through their leaves. But basically, it's like I said, those three things. And then roots are broken down by types of root. There are tap roots. Most plants that have broad leaves, you know, this is the case where they have a netted vein structure on the leaf, and they have generally tap roots. A classic example of a tap root is a carrot. Fibrous roots. Grass have fibrous roots. All the roots come from the crown, right at the soil surface. There's not one dominant root, there are just many roots. And then the last kind is adventitious roots. And one that you think comes to my mind right away is cornstalk, what some people call the brace roots that come out at the base of the corn plant. Another example is if a plant lays over in the field, you might often see, depending on the species, you might often see roots developing from that part of the plant that's touching the soil. Those are adventitious roots. And then just to set the stage, how do roots grow? Three ways: cell division, cell elongation, cell differentiation. So cell division occurs at the tip of the root. And it starts right at as the embryo germinates. There is a growing point that's going to go down, and there's a growing point that's going to go up. Both of these growing points have apical dominance. So the up is pushing the plant up, and down is pushing the plant down, and continues going in that direction. The cell division, however, is not how the root gets longer. Cell division adds cells to the root. Cell elongation happens, the cell gets longer, and then that pushes the root down further. And this continues with cell division. That takes it down a little bit, then those cells elongate, and it keeps going like that. Cell differentiation is when you have to have like xylem, which takes the water and nutrients to the top, and phloem, which brings sugars down from the leaves. And there are other structural cells that are in a root. So that's cell differentiation. That's how the nature of the cell changes from what was present at cell division.
All right, so we're going to go through tactics right now and improving your soil structure is really one of the main focal points that we discuss. If you think about soil and a comparison for that, think of any building and the foundation in which it stands on, and how critical that is in the the lifetime of that building, and the repairs that are needed on that building. If you don't have a solid foundation, then you're going to have structural issues all the time, and it's going to be ongoing, and it's going to be very costly to maintain that structure. If the foundation completely fails, then you may need to start over from scratch. So, we talked before about anchorage and support of a root system. This directly affects, the soil directly affects those two aspects when you're just talking about the foundation structure of a plant.
So soil is really, they are mineral components that have been weathered to produce soil. And there are three basic types of ingredients that make up soil. That's sand, which is the coarsest, silt, which is the between sand, and clay, which is the finest. And then what happens is they all get together and create a soil type, which is how much sand, how much silt, how much clay. And it's really pretty important that you know what your soil type is so you know what kind of performance you can get out of that soil. So you need to have, plants need to have a aggregated soil. What that means is the sand, clay, and silt form aggregates, which are like little spheres, little balls, whatever, just all laying in the soil. And this creates channels because the space between the aggregates is where the soil water and soil atmosphere are present. With the in the soil, I think all of you know there's water in the soil, but maybe you don't think about that there's air in the soil. There is, and that air is just like the air that we breathe, only this is in soil, but it still has 36 to 40% nitrogen, and it has carbon dioxide, and it has oxygen and other gases. It's very representative of the air above the soil. The channels are also created by living organisms. Fungi put out mycelium, worms create channels, that's pretty obvious. Insects do that as well, and worms actually secrete a sticky leaf behind, and that helps to form up aggregates. So how can we, what can we do that will help make a better soil structure? Well, one is aeration, and by aeration, you're actually increasing the soil surface so that there's a greater opportunity to get gas into the soil near where the roots are. If you add organic matter, that creates the opportunity to have structure. The organic matter will actually become part of the aggregated part of the soil, and it will be an opportunity for attracting microorganisms, which are going to get in there and work on that organic matter. The less soil compaction, the better. So we have found, and I say we collectively have found that over the years that the less we drive heavy equipment over that soil, the better that soil is going to be. It's pretty obvious. Weight squeezes things together, and that decreases the channeling. We like to think about promoting no-till if you're in agriculture, or even if you're in home gardening. The less you disturb that soil, the better. Every time you put a shovel into that soil, you're breaking up the mycelium of the good fungi in the soil, and in fact killing some of those. If you have poor drainage, think about opportunities to improve your drainage, like tiling the soil or things of that sort. And then be sure you know what the pH is and lime the soil to increase the pH, because if you have an acid soil, that affects the clay and it tends to actually cause compaction.
Dr. Bob, am I correct in thinking that some of those, like when you consider aeration, which in the lawn care world is a major component of a lawn care program, that is basically the equivalent of being able to transport nutrients by plane versus by car. Very efficient to be able to transfer something that way, but it's more costly to do it. It's not available on an everyday basis to everyone as their car might be. So if you needed to be mobile, then it makes sense to have that mobility similar to the way that our product kind of it increases that mobility on that everyday scale.
Right, and like I said, also you aren't just creating holes in the ground; you're actually increasing surface area.
Yeah. All right. Tactic number 2: soil fertility. This is basically exactly what it sounds like: soil and plant fertility, and this is what farmers and lawn care operators and landscapers have been focused on quite a bit for a long time, and this is what everyone thinks about when they say, all right, well, we're going to start a lawn care company, or we're going to take care of the trees and shrubs, or the turf for as a landscaper. This is the components that play a factor in that.
So it's pretty obvious, and I know most of you are. I should say, I would be surprised if it's not all of you are applying soil nutrients to your soil. And an important step, which many of you might skip, but is soil testing. You really won't know what your soil has and what it needs if you don't test the soil. There are 3 major nutrients. They're nitrogen, phosphorus, and potassium. Without those 3 nutrients, the plants are not going to function. Nitrogen is important because it's a component of amino acids, proteins, and proteins. Some proteins are enzymes, other proteins are for structural purpose. Nucleic acid and chlorophyll. So if you have any idea at all what those biochemicals are, you have a sense that this is really important to the life of the plant. Nitrogen is important for that. Phosphorus plays a key role in photosynthesis. It's in the chemicals that are associated with phosphorus. They're associated with energy transfer. We're taking energy from the sun in the form of heat, and we're transferring that in the soil to build up molecules that eventually become sugars and starch. And this is the energy. Sugars are the energy that drive the plant, and it's ultimately the energy that goes into feed for cattle or feed for bacteria. It gets transferred. Starch is a way a plant stores energy. So phosphorus, important.
Dr. Bob,
Yes.
when we're considering phosphorus, there's 11 states in the United States that have phosphorus bans. So what do you think the long-term effect is of having that phosphorus ban in place?
Actually, it's not bad. The soils are rich in phosphorus. All soils are. The problem is the phosphorus is not in usable form. Yeah. And but the good news, and we'll talk about it a little later on, is that bacteria and fungi associated with our products help to make that phosphorus become available. Now, if you're trying to grow a new crop or establish a new lawn, then you need to put phosphorus in that top layer where the seeds are in order to give that lawn or new crop a chance to get established.
How does tilling, we had talked about tilling before, how does that affect the phosphorus availability?
Well, it'll just mix the phosphorus that's in the soil around, bring some up from the subsurface, and but it's not making it available. It still takes the action of biology to make it available. And the last major nutrient is potassium. It's involved in enzyme function. It's kind of like a catalyst. It needs to be there in order for the enzymes to do what they do. It's involved in the translocation of sugars and other chemicals throughout the plant. It's a signaling element. It sets the signal that calls for root cell, it says DEL, but root cell differentiation. And it's involved in cooling the plants because it actually triggers the guard cells on stomata. Stomata are the openings in the leaves that lets oxygen and moisture get out. When the guard cells fill up with potassium, they become very turgid because the potassium is a cation and it attracts water into the cell. When the potassium leaves the cell, there's just one cell on either side of an opening. When it leaves the cell, they become flaccid, and it looks like slamming the door shut, so that nothing can get out. When it's open and water is moving out, water is evaporating, and that leads to cooling of plants under heat problems. So there are a whole list of secondary and micronutrients. We're not going to go through all of them in any detail, but oh, there they are. Okay, great. So I was looking down at my own notes. So calcium, magnesium, and sulfur are the secondary nutrients. Magnesium is a real important player, as is calcium, because they both promote the development of root hairs. So root hair is a extension of a cell on the epidermis, that's the surface of the root, that goes out into the soil, and that's where the water is absorbed through the root hairs. As the plant root grows, the root hairs slough off. They're always down near the active area where the root tip is, and the cells are differentiating. But at any rate, root hairs are always being regenerated, but in a new spot further away from the plant, from the above ground part of the plant. But without root hairs, you won't get any absorption of water. And water, when it's absorbed, brings along the nutrients. So that's calcium and magnesium. Really, really important. When you do your soil test, see where you are on that. Calcium's probably all right, especially here in the Northeast. There's plenty of calcium in the soil, but magnesium could be a problem. And then boron is also important because it's essential, like we talked about before with potassium. Boron's involved in the transportation of sugars through to the roots from where they're made in the leaves. The other ones there are all important, but we're kind of focusing on roots today. So I also want to point out back to the major elements. Potassium, make sure I get that straight. Potassium is very important in triggering root differentiation. Potassium plays a role in a lot of things like that. It's more like a catalyst. When it's present, other things happen, and then root differentiation can take place.
Yeah, when you think about lawn care, everybody focuses on nitrogen and phosphorus, but you don't realize how much of a role potassium plays in not only the effect that it has on how effective the nitrogen and phosphorus are, but all the secondary and micronutrients as well.
Another neat thing to know is that nitrogen and phosphorus create signals, and roots grow to nitrogen and phosphorus. Potassium doesn't. So when you apply potassium, it ought to be applied with the nitrogen and or phosphorus, because you want to put them in the same proximity, so when the plant travels to pick up the nitrogen, it's going to be able to get the potassium as well.
All right, we're on to plant hormones.
So these are really, really important in a root. And not to say they aren't important in shoots and flowers, they are. But I want to focus today on what plant hormones do for roots. So the first one we're going to talk about is auxins. And auxins are chemicals that promote plant growth. They're naturally occurring in the plant. And actually the source comes from the seedling itself. It comes from stems, it comes from leaves, it comes from roots. Also, auxins are produced in the soil by bacteria and even fungi that are in the soil. So this is a case of where the think back to that those pea roots. They were being stimulated by auxins that they were getting from the bacteria that were in the product that we put on the soil. And when we talk about these hormones, you can't think of them as individuals. They all act together. We're going to go through the ones that are important, but they all trigger each other to do certain things when they're in certain proportions in the soil near the roots.
I think that's really an important point when we talk about just with our product and how we're trying to generate a result through biology and why we incorporate the diversity of biology into that. You oftentimes see other products broken apart into specific segments, and they can be effective at times. But if you don't have those other secondary components to enhance that availability or effectiveness, you may get no result from it.
That's right. So one other piece of information for you. Auxins are naturally occurring products made, or chemicals made in nature. But there are man-made auxins, and they are, in fact, herbicides. So 2,4-D, 2,4,5-T, dicamba, these are all synthetic versions of auxins and put down at rates that are phytotoxic to plants.
So they basically grow themselves to death.
That's correct. Cytokinins, again, are manufactured by roots and by bacteria and fungi. These hormones are responsible for the maintenance of the dominance of the tip of the plant on the shoot that makes it grow up, and the tip of the root that makes it grow down. And then also in combination with auxins and gibberellins, they're responsible for the cell elongation. So the next one is, in fact, gibberellins, which is its major role is cell elongation. They're produced by young seedlings. That's where it happens, right after germination. And in roots, they promote elongation. And the auxin works with the gibberellin on that ability to elongate, because auxins create elasticity in the cell, so that cell, which once was very small, now is going to grow rectangularly in length. And some of them are, if you look at them under a microscope, are really a lot longer than the cells that are coming out of the root, from cell division.
So when we talk about cell elongation and increasing shoot tip and root tip, it maybe seems obvious to some people and not obvious to others. What's the advantage of having that expanded root system?
It's growing toward the nutrients. It's growing toward the water. There's a limit to how far it can grow, but that's what's driving the growth. For the most part, it's moving through the least resistance. So it moves along the channels. That's why we want to have aggregation. If we hit a hard spot, it's going to be difficult for it to penetrate. It may then turn around and go laterally across that hard spot until it finds a crack that it can penetrate to go down. It wants to go down. And you're increasing the surface area of the root, so give you more area for uptake of moisture. But again, remember, the uptake only happens from the area of the root that has root hairs, and that's constantly moving down as the root grows down. And then there may be additional roots coming from the top that continue to tap that area that the other root has grown through. So ethylene is actually a gas This is the one that used two obvious examples. Uh, Commercially, we use ethylene to ripen bananas, ripen tomatoes. They often tell you put your tomatoes in a bag and seal the bag, and they'll ripen. That's because they're naturally putting off ethylene, and the ethylene, if it stays, builds up in concentration and triggers the ripening. And that's what goes on. They have actually ripening boxes that they put crates of pallets of bananas in, and just gas the whole room, and the bananas turn yellow. They're picked green, shipped green, and they go into that room green, right at the grocery store distribution point, or the fruits and vegetables guy's distribution point. Um, but ethylene stimulates auxin production in the root tips. It induces root hair growth, and in cases of flooding, where the oxygen stops the cell from dividing because it kills it, it initiates lateral roots. So it's a form of differentiation. So we get a new apex, new roots growing down.
Speaking of lateral roots, we should probably go to the next slide.
Okay. Abscisic acid. This induces the lateral root growth in responses to stresses like salt or drought. And it also regulates cell elongation in terms of longer elongation or less elongation.
So you had mentioned flooding. So we have two obvious major cases of flooding right now that have happened in the United States, one in Texas, one in Florida. Based on what we've talked about already, what are some of the problems that they're going to face, and just with the plant survival because of the flooding?
Well, the longer the flooding, so in Texas it's a bigger problem because it's holding that water, and than it is in Florida where it's draining out. But where you have water holding above the plant surface, all those channels in the soil are filled up with water, and essentially the roots drown because they need oxygen. Without oxygen, they can't respire. If the roots die, and also like a grass, everything grows from a growing point, which is right on the soil surface or just below the soil surface. So all the leaves, all the roots come from one little dividing area. It's like a growing plate on a bone. So that's also underwater. Or like in the wintertime, if you get freezing over it, and if you cut the oxygen off, that growing point will die, and the grass is dead. So same thing. So the same thing's going to happen to shrubbery. It's all matter. It's a function of time. It's a function of how long it's there. But it's a very good chance that the ornamental plantings and the lawns are going to be dead.
Does it matter if the entire plant's covered or just the root system?
Root system.
Okay. So even if you have standing water of 6 inches and you've got a 4-foot shrub, you're going to have an issue with the root system being choked out.
Right. Now, again, it's a matter of time, and I'm not an expert enough to tell you how much time for each species, but
sure, it'll have an effect.
Yeah. So what can we do to make sure that there's enough plant hormones in the soil to make sure that we are able to challenge the roots to get the most out of them? Well, when you plant something, you can use auxins, cytokinins, or other hormones as a root tip, and that will really encourage roots to grow out and get that plant established. You also can add mycorrhizae to the soil at the time of seeding. Mycorrhizae are fungi. We're going to talk a little bit more about them on the next couple of pages. And you can add bacteria to stimulate root growth at both seeding and post-seeding. So the last two things, adding mycorrhizae and adding bacteria, that's the business we're in. That's what we do. We sell that. We develop a very unique mix of bacteria and fungi, offer it to you in the form of Bio 800 PB1, the other products, the granular products, the fertilizers. And so we can add these things to the soil and get a good effect. And it's interesting, there are people that pick certain bacteria and promise a certain effect. You said it earlier, our product is a very diverse product. 800 or more species of bacteria and fungi in the product. And that really sets us apart. So the next tactic is talk about the bacteria. So bacteria are naturally occurring in the soil. They function in a way to make nutrients available to the plant. They convert nitrates to nitrites, or the other way around, nitrites to nitrates that are available for uptake. They convert ammonia to ammonium, which again is available for uptake. The presence of the bacteria around the roots discourage plant pathogens. Why are the bacteria around the roots? Because plants are really rather inefficient organisms. The leaves are there; they're a factory to make sugars through the process called photosynthesis. That sugar is pumped down to the roots, and 30 to 40% of the sugars that are made by the leaves actually are pumped out of the plant through the roots into the soil. So why are the bacteria laying there right around the roots? Because that's where the food garden is. And their presence, they're like a competitive displacement. They don't allow other organisms, especially pathogens, to get to those roots. They also produce all those hormones that we just talked about can be and are produced by bacteria, so they help promote root growth. Some of these species actually produce biosurfactants. In soil, this is really important because the biosurfactants actually help to maintain the granulation of the soil, and they're a natural wetting agent, which is attractive to water in the form of moisture that gets held on to the aggregates, making it available to plants for a longer period of time. And the last thing I want to mention is something that might be new to you is bacteria induce systemic acquired resistance. That is, they send signals, biochemical signals to plants. They're stimulated by maybe disease or maybe insects that are in their area, and they're stimulated and they produce a chemical that the plant actually senses as a warning. It's like the fire alarm going off. And in response to this warning, the plants actually mount a systemic resistance. It's called systemic acquired resistance, and known by the scientists as SAR. So that's a pretty neat thing that happens between the bacteria and the plants.
So then we consider, how can you incorporate bacteria? So one way that has been around for quite some time is applying compost or compost tea. We also, as you said before, this is the business that we're in. So apply any Holganix probiotic product, the Bio 800, PB1, Healthy Grow infused with Holganix. They all have the biology and the diversity that's needed to incorporate not only some bacteria, but an abundance of bacteria, and also plug all the gaps of what that soil food web may be missing.
And a neat thing about Holganix bacteria is they are different than the kind of bacteria that are currently present in the soil. We're introducing new species. There are about somewhere between 70 to 100 species of lactobacillus in our product.
This is the Bio 800 product?
In the Bio 800 product, it's also in all those products, but it's the emphasis is the Bio 800. And that's why it's a refrigerated product, because we want to keep those alive. You introduce them to the soil, they're brand new to the environment. It's like the new kid in town. They move in, do their job.
They better have a good night of sleep before they
That's
have their
right.
first day of school.
Right. And now fungi, we can look at them in much the same way. Uh, Fungi are important in the soil. Two ones that are important and helpful to plants are trichoderma and mycorrhizae. Mycorrhizae is not a species; it's a class, a type of fungi. Trichoderma is also like the bacteria in that it needs to be close to the plant roots because it likes those sugars that are coming out. So when you have trichoderma established, it will colonize roots and put up again what's called competitive displacement. Who's on first? The trichoderma is on first, and so you're not going to be. And also trichoderma induce a systemic acquired resistance, just like certain bacteria.
So what is systemic acquired resistance?
Again, that's where the fungi, in this case, secrete a chemical, a biochemical, in response to something they sense in their environment that it really may not be harmful to the fungi, or it might be. But at any rate, in response to that disease or insect or nematode, it's stimulated to put a chemical out. The plant takes that chemical up and says, uh-oh, nematodes are coming, I got to do something. And the plant will actually, it's like getting a vaccination. The plant will then mount a defense against that pest. And mycorrhizae are really one of the wonders of nature. These are fungi that have grown up to be a symbiotic relationship with plants. If you look at that picture of those roots, what looks like cloudy area, those are not roots, those are mycorrhizae mycelium. The mycorrhizae come in and live really closely associated with the roots. In some cases, like in endomycorrhizae, they actually penetrate the epidermis of the plant and become one with the plant. And if you say, when I say one, it's like having a straw. And that mycelium, being the straw, can grow much further away from the plant than the roots can. And when they get out there, they can bring moisture back to the plant. And when they're bringing moisture back, they're bringing nutrients. But one more thing that's really neat is the mycorrhizae secrete an enzyme that affects the unavailable phosphorus and makes it available and soluble, and it takes that phosphorus back to the plant.
So how can you incorporate fungi into your soil?
Well, one of the things you want to do is you want to reduce tillage, because fungi have mycelium. Those are those thread-like things we saw growing in the soil. So you want to reduce tillage, because every time you till the soil, you're breaking up those mycelium and killing a certain amount of fungi. You can apply mycorrhizae. You can go to your garden store. Many of you guys may have it in your inventory. So there are products that are just mycorrhizae that can be applied at planting time or after. Or you can apply the Holganix line of products, because they all have mycorrhizae and trichoderma in them.
Well, I will be specific on one, and you notice the PB1 GOF 200 is in there. The PB1 LTO is not, because that is one of the main differences between the two products, is that the PB1 GOF has endo and ectomycorrhizae, and the LTO doesn't, whereas the LTO is also more focused on the nitrogen-fixing bacteria.
So the last thing here is prebiotics. So what is a prebiotic? Well, bacteria and fungi need to have food. That's why they associate with plant roots, because the plant roots secrete sugars. So basically, prebiotics are sugars. And So if you mix sugars with a fertilizer, an example of that would be Holganix Blue Sky has sugars in there and other food for bacteria and fungi. Uh, Another example would be the Bio 800. We have in there sugars and other foods that will sustain the life of the bacteria and fungi that are in the can.
Is that true? I've heard the same thing regarding some of our fertilizers as well, where there's food source available in that.
Like for instance, the Healthy Grow.
Yes.
Has a sterilized chicken manure, and that's food for the bacteria.
So how can you incorporate prebiotics?
Well, again, apply the. You can buy products that have molasses in them, sugar in them. Have to read the label carefully, or you can apply Holganix products, and they have this stuff in it.
All right. And one of the things I want to focus on is the use of the term prebiotic fertilizer. Can you elaborate on what, because we talk about prebiotics and probiotics. Can you elaborate on the difference there, what we're describing?
The probiotics are, let's talk about in the sense of human. Probiotics are the bacteria that you can buy and mix with your juice, or you can buy it in yogurt. It's already mixed with something that you like to eat. But basically, the probiotics are the bacteria or the fungi themselves. The prebiotics are the food to sustain those organisms until they get established in mass around the roots of the plant.
So like our 21020 and Blue Sky 2100.
Yes.
Last one.
Last tactic, number 7.
Okay.
Lucky number 7.
Nutrient enhancers. This is a group of, actually, it could be living material, it could be chemical material, but the role and function of these things are to make nutrients available to plants. And so an example is Armament, which is in our product line. Armament is a complex of amino acids referred to as a polypeptide. So these are the building blocks that ultimately would go on to be a protein, but they're not a protein. They're short. They're called a polypeptide. But they're charged particles, and they have the ability to latch onto and hold on to nutrients, take them because they're soluble to the plants and become absorbed by the plant. It also, since they're a long chain and the minerals are attached at various places of the chain will break off, and the smaller pieces are what will go up to the plant. So it's like a long-term fertilizer once it's latched onto these nutrients.
Is it also true that, so one of the ways that I describe this is it's almost a magnet for the root system?
It is.
And it pulls nutrients in.
Because it's positively or negatively charged, and the nutrients are positively charged. So it's like a magnet. It pulls them to it. They stay attached. And then when the chain is this polypeptide, it really is a chain, amino acid built on amino acid and so forth. When this chain breaks down, the pieces are now available to the plant.
Okay. Which products do we carry that has armament in it?
That would be the PB1, PB1 LTO, 21020, and 0023.
And now also there are living nutrient enhancers, mycorrhizae, because they go out and take phosphate rock and bring it down to a form of phosphorus that is now soluble and can be used by plants. Actually, can be moved through the mycelium, literally by the fungi, actually taken from where they are to the plant itself, to the plant roots. And certain bacteria do a similar thing. Certain bacteria solubilize phosphate. Certain bacteria chelate micronutrients like iron, and that is also a nutrient enhancer. And these again, are the bacteria and the fungi that are in the Bio 800 line.
And one of the things I love recommending to the users of our products is the combination of the diversity of biology along with armament, the component that's in some of those other products.
So pairing Bio 800 with.
Yes. So, for example, putting PB1 with Bio 800 because it increases the effectiveness. We already are focusing on the diversity and putting everything into the soil, and there's going to be a massive effect on the root system and the plant and the soil health just by adding the Bio 800. But we can actually increase that with the use of the polypeptide in armor.
You can.
Questions.
All right, questions. It's Katie's favorite part, so don't let her down.
We just did my favorite part.
Yeah, all the rest of it was Dr. Bob's favorite part. All right, let's see what questions we have.
Okay.
Most of the application reference, marketing and messaging focuses on turf, golf and sports fields. Are the products as beneficial to the rest of the garden?
Well, it's a simple answer. Is yes. Everything we talked about in terms of turf roots applies to tomato roots. And so specifically with tomato, I've had really, really good results. Year after year on tomatoes, these are commercial tomatoes grown for canning, we have seen a 12 to 20% yield increase with the use of Bio 800 products.
So I guess the rule of thumb is if it's got a root system and it's in soil, and sometimes even if it's not in soil, it's going to help.
Yes.
It's going to have a dramatic effect because of the ecosystem that it's sitting in.
So not in soil, that's really interesting you said that because we have some professional orchid growers right here in Delaware County, Pennsylvania, and they're working with the product and seeing a really, really great result. Now they take it, and because there is no soil, so they miss the leaves and those real funny looking roots that are hanging onto bark, miss that 2 times a week.
So just with a missed application.
Yeah.
And the Bio 800 products, we have different SKUs for different plant types. So she might be more interested in the bloom, which is geared towards flowers, or the tree and shrub, which is geared toward trees and shrubs.
Yep, that's true. So the 5 different aspects of Bio 800, and not just the Bio 800, but we'll use that as an example. Having the lawn, tree and shrub, golf, ag, and bloom mixtures all tailored to what the specific biology would be that most benefits that plant type. All right, next question. What would the effect be if you were to add prebiotics without a food source?
So a prebiotic is a food source.
Right, so maybe they mean probiotics. So what happens if you add Bio 800 to the soil and you don't add any nutrients?
Well, you don't add any prebiotics.
Or you don't add any prebiotics.
Well, that'd be hard to do because Bio 800 has a food source in it. So, but if you,
But not in a traditional way. I think that they're thinking NPK.
Yeah.
If you're not adding any NPK to it, what would the effect be?
You'll have an enhanced growth of the plant versus unfertilized because the bacteria and fungi make nitrogen, phosphorus, potassium, iron. It wasn't available.
Mm-hmm. Okay. Do all species of plants form relationships with endo and ectomycorrhizae? I'll let you answer that part first.
No. And I wish I could tell you the ones that don't. There's very few.
Because I'm going to follow up with it. Are there families that would not benefit from the addition of mycorrhizae?
Yeah. There are very few plants that don't live in association with mycorrhizae. But it's a list that's very, very short. I just don't know what they are.
Hasn't been worth your time to look at.
Right.
What form of fungal? I can't see that.
Propagules.
Propagules.
Are included in your product spores versus mycelium?
Well, it's hard to, if you were so first of all we purchase our propagules from a source and then add them to the product just before we finish it. It's very difficult to buy just spores or just propagules because they're all in association with each other. We prefer to have mostly spores, but again, there are mycelium in there as well, and also plant roots because they're grown on plants, actually harvested from plants.
All right, next question. In Colorado, where I live, the beds are covered by weed fabric and then large rock mulch. I am spraying the tree and shrub Holganix on the leaves. Is this effective? So as a foliar spray. How does the leaf take it in? How much of the bark has capacity to take it in also?
So yeah, the answer is yes, it's effective, but not in the sense of taking it in because the microorganisms in the product do not get absorbed by the leaves, but the microorganisms do live on the leaves. In the case of tomatoes, I would say leaf application is a large part of that productivity we have. Because again, it's that who's on first. They establish themselves on the leaves. The bacteria grow on the leaf, just like bacteria are on human skin. You know, these bacteria establish on the leaf surface. We apply it frequently on the leaves because we want to make sure that we're covering new leaves, and if it's rained, we want to make sure our colonies are firmly established. And on the leaf, they're growing and they're secreting plant hormones. So they're a barrier to pathogens, and they're a factory secreting plant hormones that are absorbed by the plants.
So the next question was, what should I be telling my new customers to expect if they choose my company using Holganix? So I would have a follow-up question here. What is your business type? So are you doing tree and shrub care? Are you doing turf care? Because that description is very different, and the result that you're looking for is different. So
this is one of the tools that we've designed regardless for those that are jumping on the Holganix bandwagon. Excuse me. It includes a bunch of communication tools to help you communicate the fact that you're using Holganix products and why that makes you special. So just as an example, there's a free brochure there that talks about the benefits from a homeowner's perspective. There's website copy and graphics for your website. There's blogs that are already written that you can steal, postcard designs, yard signs, door hangers, social media, and a letter even to designed to announce Holganix to current customers. So we do have tools and resources available to you that should help you communicate that to new users.
And if you're dealing with this on the fly, say that I'll give you a couple different examples. Say that you are a lawn care company and the customer comes out to meet you on the lawn or meet a technician on the lawn, and they say, I heard that you're using this new product. Can you tell me any more about it? We're incorporating living biology into the soil to become more environmentally friendly and increase the result that you're looking for. It's a simple way of hitting a few points to let them know that you are doing something different and doing it in a responsible way. If you are doing tree and shrub care for ornamentals, we are doing a tree and shrub program that is focused on plant health rather than the former traditional way of just pumping nutrients into the soil to let that overcome some of the obstacles that those plants would face. So it's kind of like if we were eating right and exercising to stay healthy, or are we taking supplements to stay healthy and not doing the other aspects? So there are a couple examples, but what Katie brought up as far as the 12 marketing tools to use during your Holganix launch, there is a tremendous amount of information in there, and all of which has been created with the collaboration of a lot of our end users and what they've gone through in past years and what's been most helpful for them.
So, I'd like to point out about the garden. Like here in the Northeast, we have a lot of rhododendron, and a lot of them are overgrown and not been well taken care of. If you go in there with Holganix, it's really the Bio 800 product. It's really a good marriage. We're recreating a proper soil balance of microorganisms for these plants. They really respond well, and if you put a program together of 6 to 8 applications through a summer, and come back next year and observe those plants and how they come out in the spring and what they look like next year, you're going to be really, really well pleased.
It's great that you mentioned rhododendrons. I have one at my house, one, and that's it. But I didn't plant it there. It was blocked by a tree and a hedge line. So it had some funky growth to it as far as where there was actually leaves on it. Yeah, and it's stretching along the ground to get out from underneath of other things. Well, I had since removed those, the tree and the hedge line and uncovered this rhododendron. But I used the Bio 800 on it. And because, a painter's house is never painted, I did not do it on a monthly basis. It's been done 3 times in a year and a half on that rhododendron. You can't tell that there was any, and I had to cut off all the funky growth so I didn't have some weird looking plant on the corner of my house. But it really has shown a dramatic change in how healthy it is, where it's established its new foliage. It's one of the prettiest plants I have there now.
It's really exciting.
So this is just going to be the last question, guys, because we've already gone over our time. And their question was, can you, where'd it go? What does Holganix Bloom do? So I just want to point out that when we're talking about Bio 800, it's any of the products that are in a refrigerator. So that could be the lawn product, golf, ag, tree and shrub, or bloom. So anything that we talked about in regards to Bio 800 applies to bloom. It's just a SKU that's specific to flowers. And Dr. Rob, why don't you discuss what the differences are between bloom and some of the other SKUs?
Well, in bloom, there is, it's a different balance of the organisms are different. There's a little more fungi. The amount of plant bacteria food is increased. Things like that. The response you're going to get is if these plants tiller, you're going to get more tillers. If these plants have lateral growth, you're going to get more lateral growth. If these plants have flowers, they're going to be larger and more colorful. Now, the extent of the response is going to be different from plant to plant. By that I mean species to species, not plant of the same species. But you'll see some really exciting things. For instance, 2 years ago, we had a problem with impatiens up here in the north with a powdery mildew that was just taking impatiens out. Literally, you would plant them in April, and by end of June, beginning of July, they were gone. And normally, these plants would live into through September. So I had some in my yard and had this problem, and I treated them with Holganix. I did it the Bio 800. I did it the easy way, the way the most household people would do. So, like for instance, if they were throwing a fertilizer in a watering can and just watering the plants, that's what I did. I just put 1 ounce of Holganix into a gallon of water, and every week I watered those plants. And I got the impatiens to live all the way through August, and I had it control, and the control was gone by the first week in July.
Mm-hmm. So we actually have an interesting use of bloom coming up for the Philadelphia International Flower Show, where we're going to be forcing growth with bloom. because of the time frame of the flower show. It's right after the winter. So for one of the displays, we will be using it for that purpose, along with kind of them manipulating the fall seasons.
What is the nature of the business that's doing this?
Landscaper.
Neat.
So maybe I'm jumping the gun, but we'll be doing it with Stony Bank Nurseries for their display at the Philadelphia Flower Show. But they have plants the tree with 6-inch caliper that's going into their display. I mean, they do a huge display, and they've won Best in Show quite a few times. But how are they going to get foliage on a tree in March? So they're going to be using Holganix Bloom for that this upcoming show.
And if you want to learn more about the different product lines, one of the handouts of this webinar, which you guys should have access to, is this product catalog. So that'll just go through everything on a high level.
Oh, and to answer that other question that I saw up there.
Oh, you sneaking another one in?
Dr. Bal kind of hit on it, but soil drench is better than a foliar spray.
The foliar spray is still good.
It's still good. Doesn't have the same amount of benefits.
Mm-hmm.
And as far as the time frame that would be perfect.
She's in Colorado.
Is that 7 ounces once a month? 7 ounces once a month. That would be
per 1,000.
Yeah. 7 ounces per 1,000 square feet once a month. If you figure out that rate, that would be like 2.25 gallons of Bio 800 to 100 gallon sprayer.
Or if it's a small garden,
just use your watering can.
Yeah, exactly.
I do the same thing in my house. All right. Do you have anything else, Katie?
Nope. Tomorrow I'll send you guys a follow-up email with some of the resources we discussed. Some answers to some of the questions that weren't answered today.
We can do a speed version.
Speed version?
Which product was used on the impatiens?
Bloom.
Oh, Bloom. Yeah.
Good.
Manufacturing process of Holganix Healthy Grow.
You only get 10 seconds for this.
Oh, it's a fermentation process.
Okay.
All right.
Anything else?
That was it, actually.
Okay.
So I guess I could have just kept on going.
We were skipping through.
But look for my follow-up email tomorrow with the resources. And I'm also going to give you guys access to, we can call it an advanced reader's copy of our new and improved soil science ebook. I haven't released it to the public yet, so you guys will get your hands on it first and give me your feedback. So thank you so much for coming today. Thanks for taking time out of your busy day.
Katie has miraculously recovered during this hour.
I know.
She didn't even have a voice when we started this.
You guys are like, I guess, inspiring my voice.
It's all the adrenaline.
Yeah, definitely. All right. Have a great day,
Thank you
guys.
for the attendance. Have a good day.
Bye.